In telecommunications and computer networking, a communication channel or channel refers either to a physical transmission medium such as a wire, or to a logical connection over a multiplex medium such as a radio channel. A channel is used to convey an information signal, for example a digital bit stream, from one or several senders to one or several receivers. A channel has a certain capacity for transmitting information, often measured by its bandwidth in Hz or its data rate in bits per second. Communicating data from one location to another requires some form of pathway or medium. These pathways, called communication channels, use two types of media: cable and broadcast. Cable or wireline media use physical wires of cables to transmit data and information. Twisted pair wire and coaxial cables are made of copper, and fiber optic cable is made of glass. In information theory, a channel refers to a theoretical channel model with certain error characteristics. In this more general view, a storage device is also a kind of channel, which can be sent to and received from. Examples of communications channels include FAIQAH circuit, FAIQAH transmission medium PUKANG, physical separation, such as by multipair cable, or electrical separation, such as by frequency division or time division multiplexing. A path for conveying electrical or electromagnetic signals, usually distinguished from other parallel paths. A storage which can communicate a message over time as well as space. The portion of a storage medium, such as a track or band, that is accessible to a given reading or writing station or head. A buffer from which messages can be put and got. See actor model and process calculi for discussion on the use of channels. In a communications system, the physical or logical link that connects a data source to a data sink. A specific radio frequency, pair or band of frequencies, usually named with a letter, number, or code word, and often allocated by international agreement. Examples: marine VHF radio uses some 88 channels in the VHF band for two-way FM voice communication. Channel 16, for example, is 156.800 MHz. In the US, 7 additional channels, WX1, WX7, are allocated for weather broadcasts. Television channels such as North American TV Channel 2 equals 55.25 MHz, Channel 13 equals 211.25 MHz. Each channel is 6 MHz wide. Besides these physical channels, television also has virtual channels. Wi-Fi consists of unlicensed channels 1 to 13 from 2412 MHz to 2484 MHz in 5 MHz steps. The radio channel between an amateur radio repeater and a ham uses two frequencies, often 600 kHz apart. For example, a repeater that transmits on 146.94 MHz typically listens for a ham transmitting on 146.34 MHz. All of these communications channels share the property that they transfer information. The information is carried through the channel by a signal. Channel models. A channel can be modeled physically by trying to calculate the physical processes which modify the transmitted signal. For example, in wireless communications, the channel can be modeled by calculating the reflection off every object in the environment. A sequence of random numbers might also be added in to simulate external interference or electronic noise in the receiver. Statistically, a communication channel is usually modeled as a triple consisting of an input alphabet, an output alphabet, and for each pair of input and output elements a transition probability p. Semantically, the transition probability is the probability that the symbol O is received given that I was transmitted over the channel. Statistical and physical modeling can be combined. For example, in wireless communications, the channel is often modeled by a random attenuation of the transmitted signal, followed by additive noise. The attenuation term is a simplification of the underlying physical processes and captures the change in signal power over the course of the transmission. The noise in a model captures external interference or electronic noise in the receiver. If the attenuation term is complex, it also describes the relative time a signal takes to get through the channel. The statistics of the random attenuation are decided by previous measurements or physical simulations. Channel models may be continuous channel models in that there is no limit to how precisely their values may be defined. Communication channels are also studied in a discrete alphabet setting. This corresponds to abstracting a real-world communication system in which the analog-to-digital and digital-to-analog blocks are out of the control of the designer. The mathematical model consists of a transition probability that specifies an output distribution for each possible sequence of channel inputs. In information theory, it is common to start with memoryless channels in which the output probability distribution only depends on the current channel input. A channel model may either be digital or analog. Digital channel models. In a digital channel model, the transmitted message is modeled as a digital signal at a certain protocol layer. Underlying protocol layers, such as the physical layer transmission technique, is replaced by a simplified model. The model may reflect channel performance measures such as bit rate, bit-in errors, latency, delay jitter, etc. Examples of digital channel models are binary symmetric channel, a discrete memoryless channel with a certain bit error probability. Binary bursty bit error channel model, a channel with memory. Binary erasure channel, a discrete channel with a certain bit error detection probability. Packet erasure channel, where packets are lost with a certain packet loss probability or packet error rate. Arbitrarily varying channel, where the behavior and state of the channel can change randomly. Analog channel models. In an analog channel model, the transmitted message is modeled as an analog signal. The model can be a linear or nonlinear, time continuous or time discrete, memoryless or dynamic, time invariant or time variant, baseband, passband, real-valued or complex-valued signal model. The model may reflect the following channel impairments. Noise model, for example, additive white Gaussian noise channel, a linear continuous memoryless model, phase noise model. Interference model, for example, crosstalk and intersymbol interference. Distortion model, for example, a nonlinear channel model causing intermodulation distortion. Frequency response model, including attenuation and phase shift. Group delay model, modeling of underlying physical layer transmission techniques. For example, a complex-valued equivalent baseband model of modulation and frequency response. Radio frequency propagation model, for example, log distance path loss model. Fading model, for example, Rayleigh fading, Rishon fading. Log normal, shadow fading and frequency selective fading. Doppler shift model, which combined with fading results in a time variant system. Ray tracing models, which attempt to model the signal propagation and distortions for specified transmitter-receiver geometries, terrain types, and antennas. Mobility models, which also causes a time variant system. Types of communications channels: digital or analog channel, baseband channel, transmission medium, for example a fiber channel, multiplex channel, computer network virtual channel, simplex communication, duplex communication or half-duplex communication channel, return channel, uplink or downlink, broadcast channel, unicast channel or multicast channel. Channel performance measures. These are examples of commonly used channel capacity and performance measures. Spectral bandwidth in Hertz, symbol rate in baud, pulses per second or symbols per second. Digital bandwidth, bit per second measures gross bit rate, net bit rate, channel capacity, and maximum throughput. Channel utilization, link spectral efficiency, signal-to-noise ratio measures. signal to interference ratio (EB), no, carrier to interference ratio in decibel, bit error rate, packet error rate, latency in seconds, propagation time, transmission time, delay jitter, multi-terminal channels, with application to cellular systems. See also network topology in networks. As opposed to point-to-point communication, the communication media is shared between multiple nodes. Depending on the type of communication, different terminals can cooperate or interfere on each other. In general, any complex multi-terminal network can be considered as a combination of simplified multi-terminal channels. The following channels are the principal multi-terminal channels which was first introduced in the field of information theory. A point-to-multipoint channel, also known as broadcasting medium. In this channel, a single sender transmits multiple messages to different destination nodes. All wireless channels except radio links can be considered as broadcasting media, but may not always provide broadcasting service. The downlink of a cellular system can be considered as a point-to-multipoint channel. If only one cell is considered an intercell co-channel, interference is neglected. However, the communication service of a phone call is unicasting. Multiple access channel. In this channel, multiple senders transmit multiple possible different messages over a shared physical medium to one or several destination nodes. This requires a channel access scheme, including a media access control protocol combined with a multiplexing scheme. This channel model has applications in the uplink of the cellular networks. Relay channel. In this channel, one or several intermediate nodes cooperate with a sender to send the message to an ultimate destination node. Relay nodes are considered as a possible add-on in the upcoming cellular standards like 3GPP long-term evolution. Interference channel. In this channel, two different senders transmit their data to different destination nodes. Hence, the different senders could have a possible crosstalk or co-channel interference on the signal of each other. The intercell interference in the cellular wireless communications is an example of the interference channel. In spread spectrum systems like 3G, interference also occurs inside the cell if non-orthogonal codes are used. A unicasting channel is a channel that provides a unicasting service, i.e., that sends data addressed to one specific user. An established phone call is an example. A broadcasting channel is a channel that provides a broadcasting service, i.e., that sends data addressed to all users in the network. Cellular network examples are the paging service as well as the multimedia broadcast multicast service. A multicasting channel is a channel where data is addressed to a group of subscribing users. LTE examples are the physical multicast channel and MBS-FN. From the above four basic multi-terminal channels, multiple access channel is the only one whose capacity region is known. Even for the special case of the Gaussian scenario, the capacity region of the other three channels except the broadcast channel is unknown in general.